Our universe is full of surprises. Sometimes they hide in plain sight. In 2014, the Dark Energy Survey was mapping distant galaxies. It took countless pictures of the deep cosmos. Years later, Pedro Bernardinelli, Gary Bernstein, they sifted through this mountain of data, looking for something else entirely. But they found an object that defied simple explanation. A faint point of light moving slowly against faraway stars. The object, C-2014 UN-271 Bernardinelli-Bernstein, was not just another rock. Its sheer brightness so far from the sun was a clue. It hinted at something massive from the solar system's remote frontier. Initial observations were puzzling. It sat past Neptune's orbit, where comets are usually frozen and invisible. Yet this one was bright enough to detect. This suggested one of two things: unusually active or extraordinarily large. Its slow motion confirmed great distance. Astronomers realized it came from the Oort cloud, a theoretical spherical shell of trillions of icy bodies surrounding our solar system like a frozen bubble. Archival images back to 2014 traced its path and confirmed a faint coma, dust and gas, already forming in the distant cold. So just how big is this cosmic iceberg? Most comets we know, like Halley's Comet, have nuclei only a few kilometers across. You could fit one inside a medium-sized city. C-2014 UN-271 is in a different league. This is not a snowball, it's a mountain. Hubble was pointed at the comet in 2022. Scientists separated the nucleus light from the coma to measure size. Result, roughly 137 kilometers, about 85 miles, across. Imagine more than twice the width of Rhode Island, larger than any comet nucleus directly observed. A true megacomet. With great size comes great mass, about 500 trillion tons, hundreds of thousands of times more massive than a typical comet. Its surface is incredibly dark, blacker than coal, from complex organics darkened by eons of radiation. A dark crust likely covers a vast reservoir of pristine ices and rock, a scientific time capsule made of the same raw materials that formed the planets 4.5 billion years ago and preserved in the extreme cold of the Oort cloud. These materials remain nearly unchanged. Early activity revealed volatile ices like carbon monoxide sublimating at very low temperatures, key clues to its composition. The path of C-2014 UN-271 through space is as remarkable as its size. It is a traveler from the farthest, coldest region we know, the Oort cloud. This spherical reservoir extends almost a light year from the sun. Its orbit is incredibly long and elliptical, taking millions of years for a single revolution. For most of that time, it drifts in near total darkness. Its last visit was several million years ago, long before modern humans. A subtle gravitational nudge, perhaps a passing star or the Milky Way's tide, set it on this slow inward fall. Perihelion arrives in 2031 at about 10.9 AU, still beyond Saturn's orbit. Close is relative. It will remain far from Earth and the inner planets. After its brief pass, the Sun will bend its path and it will begin a new multi-million-year trek back toward the Oort cloud, fading from view. This long, looping orbit means it is dynamically new, not repeatedly baked, delivering a fresh sample from the solar system's deep freeze. Whenever a large object makes headlines, concerns, and misconceptions arise, let's address them with clear, scientific facts. Does this giant comet pose any threat to Earth? The answer? Unequivocal? No. C-2014 UN-271 will not come near our planet. Its orbit is well understood. In 2031, it remains beyond Saturn, over 1.5 billion kilometers away. That's more than 10 times the Earth-Sun distance. There is zero risk of impact. Myth. Its size guarantees a spectacular sky show like Halley or Hale-Bopp. Reality. It will stay so far away that it will remain faint. A small, fuzzy patch, visible only with a good amateur telescope. 500 trillion tons sounds huge, but compared to planets, it's tiny. Jupiter alone is more than 1 billion times more massive. The comet's gravitational influence on the planets is negligible. It's like a single bee flying through a field of elephants. The elephants won't notice. This discovery is not a cause for alarm, but for celebration. It's a messenger from the past. By separating scientific facts from sensationalist fiction, we can appreciate this megacomet for what it is. A magnificent natural laboratory that offers a glimpse into the birth of our world. If it won't dazzle the naked eye or come close to Earth, why the excitement? Scientific value. See 2014. UN-271 is a pristine artifact from the earliest days of our solar system, locked in the Oort cloud's deep freeze. It bridges the gap between typical comets and dwarf planets, challenging formation theories. Did it grow from clumping icy pebbles or form via rapid collapse of a dense clump? By observing density, rotation, and surface features, scientists can test those models. A dark, carbon-rich surface shows radiation processing, while sublimating gases reveal hidden volatile ices. We can study it with powerful tools, ground-based radio telescopes, Hubble, and the James Webb Space Telescope. Each spectrum, each color measurement, each coma gas analysis adds a piece to the puzzle. We are watching, in real time, the outgassing of a 4.5 billion-year-old fossil. In the grand narrative of the cosmos, see 2014 UN-271 Bernardinelli Bernstein is more than a passing curiosity. It is a profound reminder of our origins. A direct link to the creative epoch when planets, including Earth, were built from countless smaller bodies, like this one. While inner solar system building blocks were melted and remixed, this megacomet remains a nearly untouched sample of the initial recipe. Its study will continue for years, refining models of planet formation and solar system evolution. The water in our oceans, the carbon in our bodies, the air we breathe, elements forged in stars and delivered by comets and asteroids. By studying C-2014 UN-271, we study our own deep history. Its quiet passage is a calm, confident message from the deep past, telling a story not of destruction, but of creation. The cosmos is speaking, and we are fortunate to be here to listen.